Welcome back, Kerbal Knots. So, since the last time that we launched, I have launched a mission to provide communications, so that way when we have our science data that gets to be full, which it's already starting to get pretty close, hopefully we can transfer some of that. The relay still a little ways away. You can see it's right here, and we still don't have contact, but they're both on their way to Duna, so we should be able to catch it sooner or later. So both missions have a correction burn in a little while, and so we're going to do both of those burns, and they should put us on a pretty good path. This one still won't quite have us at the absolute optimal trajectory, but it'll be pretty close. And our satellite has a little bit better path for whatever reason. So let's go ahead and get ourselves into position. Just a little tiny burn, so we're gonna go ahead and not worry too much about the timing. So many things. Okay, let's just go ahead and burn. You can see we're getting closer. Let's go ahead and focus on Duna. Well, you can see we're getting pretty close here. There's a reason why I stopped at this point, and I believe that reason is that I tried to get a little bit closer and I was losing the initial point of contact, so it wasn't working right. That's okay. We'll do another correction burn. This is how real missions actually do things for an interplanetary trajectory. They'll have a series of planned maneuvers that they will execute when they can. And so this is my relay satellite. It's more or less based off of the infrared satellite, except for I've replaced the smaller dish and the satellite with a huge dish. This will certainly give us the communications we need when we get close, but we're not that close yet. And you can see it has a lot of delta V still. How much long? Still got a day. I hope we get close enough soon. I think we are getting closer to the two spacecraft. I think are approaching each other, but they're not super close. And I'm not quite sure at what point in time they will get there. You can see that the spacecraft that left earlier is actually getting there a little bit quicker. Or the spacecraft that left later is getting there a little quicker. It often happens. But you can see that our correction burn is considerably larger, the relay satellite, than the previous one. Part of that is because we don't even have we didn't have much of a path before. Let's go ahead and we're going to end up below the pole, which is perfectly fine. Okay. Perfect. Actually, we're going to dip into the... Let's go this away. Just a scooch. good. That was more than I intended. Sorry for the back and forth. What I'm trying to do is to just barely hit the atmosphere of Duna. My keys seem to not be reacting fast enough. Yeah. Okay, I'll try one more time. Yeah. Keys are not reacting fast enough. That's okay though. So this guy is going to have a really close pass already. The other one, it's not going to be quite as close, so we're going to have to do another correction burn. We'll do just a tiny, tiny one once we hit Duna's orbit with this guy. But with our manned mission then, or Kerbal mission, we will need to... That's trying to get the asteroid. We're actually really close to an asteroid. Interesting. We're kind of going in the same trajectory. Huh. Oh well. So we don't have a ton of fuel left here, but we should have more than enough to do an aerobreaking pass, which is what we're going to try to do. Okay. Let's just go ahead and go fast for a little while. See if these two get close enough to talk to each other. Nope. Okay. Ah well. We'll add a maneuver. Just a few hours. Focus our view here on Duna. This trajectory planning can be a mess. That is the same problem I was having before. Okay, not gonna be able to do it yet, so we'll just keep playing. I think what's happening is we're actually getting just out of the what's called the hill sphere. Okay. Come on. Still not able to talk to each other. Wow. This is the most powerful relay antenna that I can get. Okay, I'll try one more time. We'll add a maneuver here. Let's see if we can get this time. Nope, we're still doing it. I think we're just gonna have to take a pass. Okay. Well, I'm gonna switch over to our satellite view, which will not have a problem. Real space physics doesn't have this problem because of something that's known as the three-body problem. Basically, all of gravity, or n-body problem really, all of gravity is actually affecting everything all of the time. But Kerbal physics doesn't do that. You can see that our manned mission is actually getting a little bit further away. How long? 16 days. Yeah, let's just go ahead and warp till there. You can go faster than this though. We're gonna go just inside the orbit, and then we can do some fun stuff. we are about to... We've never been here before. Do we have science of any kind? We should have. Yeah, we have at least a gravity detector. We'll transmit that just to get our science. Now, one of the things that is modeled, the solar panels do not produce as much power when you're this far out. So that is actually true, and it's something you have to take into account when you're doing a Mars mission. So what's our periapsis now? So let's just try slowing down a scooch, maybe? Nope, that's not taking us the right direction. We probably want to actually go down this direction, I think. Nope, exact opposite. Whoops. So the atmosphere here starts at about 50 kilometers, and it's pretty thin even till the surface. Satellite has more fuel, and I'm not super familiar with the atmosphere. So we're gonna go with this, just to kind of get us a feel of what the atmosphere is going to be like, so when we do our manned mission soon, we should be safe. Hopefully. It'll be fine. Okay. Oh good, we have an atmosphere scanner on here. May as well log that pressure. No pressure. Thought I had a temperature sensor somewhere on here, but I probably... Oh, there we go. Log the temperature and send it too. How's our battery power? Pretty low. Not really surprising, we're transmitting a lot of data. Okay, so we're just gonna go ahead and warp here. Actually, it's... yeah, auto warp. Okay, so we're going to try something that's called an aerocapture. Partial aerocapture. We're not going to do a full thing for this mission. Oh. Whoops. I forgot that these are the type of solar panels that you can't take in. Oh well. Good thing we have these ones. It'll be fine. So we're coming up on the atmosphere. And at this point in time, we're in the atmosphere. So I'm actually going to test a bug that I thought I've seen in the past. This is probably a really dumb thing to do. Oh, we're actually considered inside the atmosphere. That was a very, very dumb thing to do. Oh boy. I forgot this is an unmanned vehicle, so if it has no power and I am not in sunlight, which I am not, we have no way to fire our thrusters. Oh boy. So how slow? We're in a really low drag state. So we would need a deeper pass from this for our manned mission to be able to do anything useful. Okay, lesson learned. So we'll try more for a 30 to 35. In fact, we can do aerobreaking to slow things down once we get above the atmosphere. So, okay. Let's see how things are going. We're outside of the atmosphere now. And as soon as we get a little bit of electrical charge, then we'll reboot. Real spacecraft actually do that, although not typically interplanetary ones. Oh boy, this is not good. We'll fire this on retrograde. We have a line with a red. Wonder what that is. Weak mission, obviously, but it must be on the other side of the sun. Interesting. This is not the right burn angle. You see, our periapsis is now 0. So we want to burn something more like this. Sorry if you're hearing that. Telemarketers. Lovely. Okay. So we want to be about here. We don't want our periapsis to be any lower. There we go. This is pretty good. And come on. You can do it. You can do this. Okay. We are now in a very highly elliptical orbit. We're going to do what real Mars missions do, although it's the orbital period here, 18 days. Real mission would burn it down a little bit more, but yeah. Let's just switch over to here, see how long it is until our close approach with the manned mission. We want to be in a good spot for capture. How long is that? "81 days? Okay. So that's plenty of time. So we'll switch back. I don't know if it'll let me do. Oh, lovely. Okay, switch to. You know what? I'm gonna slow down just a little scooch more. Whoops. Let's do it more like here. And I actually want to be... We'll try this. And this is 2 days. So just that little bit of extra fuel has greatly dropped our orbit. So most modern Mars orbiters have done some... we just skipped out of the physics. Whoops. Okay, that's enough of a problem and annoying enough that I am going to... What's going on? Do I not have electricity? No, I got plenty of electric charge. "4 days. So the Mars Reconnaissance Orbiter, which I worked for once upon a time, in its initial capture orbit, it was something of a period of like 35 hours. And it would go through the atmosphere like we're about to do, and it would have the solar panels placed in such a way to slow it down. And over the course of 6 months, it slowed down until it was able to be captured into something much more useful. I'm not going to fall for that one again. But I will try to transmit data that's not nearly as complex when we're going through the atmosphere. Well, we may as well get these basic ones out of the way. When we leave the next pass, then we will do the atmospheric scan to send that. So this isn't going to be super exciting, but keep an eye on our apoasis here. Notice how quickly it's dropping. Now, in just this single pass, it's not super low. We've been able to reduce our period considerably. And we're only halfway through it. So the first few passes they took very slow and gentle just to kind of get familiar with it, and they could eventually save a significant amount of fuel at the cost of 6 months of mission time, which they only did the most minimal of science pictures. They took a few pictures of the, well, among other things, of the Spirit and Opportunity rovers, which kind of helped them. Yeah, we probably don't want to do a dip that deep again, but 35 is probably a good target altitude for our manned mission, maybe even no lower than that, actually. We're eventually gonna land, but no, we'll do 35 for the manned mission. You know what? For the purpose of this mission, we are good. So I'm gonna go ahead and raise our apoasis, or perigee, so we're not in the atmosphere. And we will be good. So we're going to try to do, this is what you consider aerobreaking, where you're taking very slow, careful maneuvers that take an extended period of time. You can also do what's called aerocapture, where you don't fire your thruster at all to enter the atmosphere. That you instead will rely entirely on... Sorry, I got excited for a second. I thought we had communication with our manned spacecraft, but we don't. You rely almost entirely on the atmosphere to slow it down. You just raise yourself up a little bit once you get outside of the atmosphere. So that uses much, much less fuel, but it's never been done in real life because it's very, very difficult to do. I mean, to some extent, when you re-enter Earth's atmosphere, that's kind of an aerocapture, but an aerocapture into orbit is very difficult, to say the least. Okay, where are we at? Hi, Duna. Hi. We should be getting close enough here soon. I want to see that red line. Aha, yeah. So it's able to talk to a relay satellite that's clear on the other side of the system. It's pretty good. So we're getting close. Let me see if I can do a maneuver here that now that we're much closer, that will get us into a better position. It's entirely possible that I can. Nope. Alright then. We'll try again. What about here? You can see that the maneuver, the amount of fuel goes up drastically to do these maneuvers. As you get closer, but unfortunately we don't have much of another choice. It's lowering. Well, it's still doing good. Okay. I'm going to... Actually, let's slow down just a smidgen here, where we're at right now. The best thing probably would be to do a radial burn. I'll keep that in mind. So what I'm gonna do here is to keep burning until we just barely lose the close approach. And there, we lost it, so I'm going to burn just a little bit so we get that close approach back. And that will be our maximum fuel efficiency. I don't really have enough fuel to... that's not a lot of fuel. I don't think I have enough fuel to orbit and land this thing. There we go. Gotta get closer than that too. Okay. So that goes out, and I lose it if I go that direction. And if I try it out here, what happens? That's promising. Okay. So, if I do a slowdown here. Nope. Alright then. So somewhere around here, I just have to slow myself down a little bit more. Slowing doesn't do it. It's got to be a radial burn. Okay. I don't know what the magical thing is that it suddenly works there, but I will take it. Take it gladly. So remember that we have to get to about 35,000 kilometers. 35,000 meters, 35 kilometers. Very, very close to the surface here. It's amazing what burning in the right direction can do for your fuel efficiency. And in the atmosphere, there we go. This will do. Whew. All right. See the direction that we're approaching from. The planet's actually catching up to us. That means we did a really, really horrible insertion. Oh, that's bad. That's awful. Oh well. Because Kerbal. Hang on. I think we're close enough now where... Yep, we have access. We can transmit our data now. You have enough battery power, we might even be able to do that. Look at this electric charge. Wow. How's our missions doing? So we need to orbit Duna. Oh, we're supposed to have a facility with 11 Kerbals. Whoops, I didn't read that one right. Oh well. I suppose we could dock another mission to this thing, but that's not too likely to happen. Okay. Well, I'm gonna go ahead and warp to here. So we got all of the science transmitted, good. Let's load this thing actually up with more science because, yeah. I have a crew report. Oh, that must have been from, okay. Bill, I need you to go take the data, and we may as well get a EVA report while we're out here. And we will get another crew report. Oh, we can actually transmit that home, why not? We'll log some gravity data. Did we clean these? Yeah, we did. So now we're gonna go collect all this lovely science data. I'm gonna do this high up orbit stuff, and then the lower stuff I will do off camera. What I'm gonna do is get us into orbit, and then we will do what? Once we're in orbit, then we'll... Oh, I forgot to log the temperature. Ah. Once we're in orbit, then I'll do science stuff and whatnot, and then I will bring it back when we're ready to land this puppy. Let's rotate this so that we have a better view. Oh wow. This will be so much easier to do with sunlight. Log temperature. I didn't put that in either. Okay. And do we get another gravity? Okay. 2 more experiments for you to capture, Bill. Poor engineer, he's just not doing anything useful, and so he's... that's okay. We had a duplicate, so we want to clean the experiments, and let's level up. Now that we're around Duna, then several of our guys can level up, so we now have better scientists in here. Look at this, they're getting 12 science per day almost. And we don't even have full data. That's amazing. Okay, so we have our communication, we have our pass. Let's go ahead and take us to here. Ooh. Okay, we don't have power, so we're going to retract our solar panels. Breathe, everybody. Breathe. I'm actually going to orient us anti-normal. Which normal doesn't matter, but I'm gonna try to slow us down the most that we can. And if it looks like we're not slowing down quickly enough, then I will switch us to retrograde and we will fire our engines a little bit if we have to. We're in the atmosphere now. So far this looks like we're not gonna slow down enough. Ironically, it seems like the atmosphere knows that and is trying to help us out. Yeah, we should have taken a deeper dive. But that's okay. How are we doing? Let me close some of this junk up. Okay. We're doing, I think we'll slow down enough. Actually, I'm gonna burn a little bit more. And let's try to point us normal again. We're getting pretty close. Duna's such a pain to get everything right. But that's okay. That's why we like it. Okay. We're not gonna make that. So we will fire our engine some more. Actually we want to... What was it, this direction? Yeah. Okay. We're now almost in... There we go. Alright, so we have a nice inclined orbit. We have communication mostly with Kerbin restored. I think we're in a good place to end this episode, so thank you very much for joining me. Let me know any questions or comments you guys have. Thank you so much for all your support and for sticking me through this with me. Wow, words. And we will see you next time. Take care.